All right, welcome back. Last day of this section 8.3. Just going to keep this brief, do a couple of additional examples just for some more practice. EQ is how do I graph rational functions, same as section 832. And so for a quick warm-up, let's find the holes and vertical asymptotes of each function. You'll notice that this one's already factored out. So I see an x minus 4 in top and bottom, and that's actually the only factor that cancels, which means I only have one hole in that graph, and that is at x equals 4. For graphing purposes, I am going to actually need to plug 4 back in and figure out what the coordinate is, so I'll do that in a minute. I see that the vertical asymptotes are at x equals 3 and x equals 2. Just to kind of, again, keep this organized, these remaining ones give me the vertical asymptotes. The canceled out terms give me the whole of the graph, any holes that there are in the graph. And then finally, didn't ask for x-intercept, but it's just so obvious and so open that I'm just going to do it anyway. So the remaining factors in the numerator are going to be the x-intercepts, which are 0 because of this. And then this one, the x value that makes 0 is -2. So I have 0, 0, and -2, 0. And those are my x-intercepts. Okay. Again, to plug in, to actually find the coordinates of the hole in the graph, I would need to take 4 and plug it in. I'm not going to plug in 4 to the original. I need to plug in 4 after I take out the x minus 4, because otherwise I'll have 0 on top and bottom. So if we think about this, this would be 4. If I plug in 4 in the x plus 2, this would be 6. And the bottom 4 minus 3 would be 1, and 4 minus 2 would be 2. So if I multiply the tops and bottoms together, I would end up with 24 on top. That's 4 times 6 over 2 on bottom. So the whole is going to be at actually 4, 12. And I get that from plugging in 4 into all the factors. Again, for the sake of graphing, I do need to know what the coordinate of the hole is. So there's that. If the equation, or if the function's not factored, like the second one, we need to go ahead and factor it first. You'll notice that both of these are just x squared trinomials, which means I can just do the standard factoring. What multiplies to -18 and adds to 7, and that's 9 and -2, which means the numerator could factor into x plus 9 times x minus 2. And on the bottom, I have what multiplies to 8 and adds to -6, adds to -6, and I find that's going to be -4 and -2. So I got x minus 4 and x minus 2 on the bottom. Right away, I see that I'm going to have 2 points of discontinuity, or 2 numbers that are not in the domain, right? If I were listing the domain here, I would say x can't be 4 or 2. So I need to do that before I cancel. But here I see I got some cancellation there. So this is my simplified version. So I would have a vertical asymptote at x equals 4, a hole in the graph at 2, something. And to find that something, I'm going to take 2 and plug it into both those x's. This would end up being 11 on top and -2 on bottom. If I plug in 2 to both x's. And 11 divided by -2 would give me -5.5. -5.5. So that's the hole in the graph. And again, this was not asked of us, but the x-intercept is what makes the numerator 0, and that is -9. So there's all that fun stuff. That was just a little brief intro to how we're going to find some of these characteristics without actually graphing. So we're just listing out what are those characteristics. Okay, I'm going to run through 2 examples real quick of graphing. just to kind of, again, get another refresher. First things first is the horizontal asymptote. I see that the largest power is in the denominator, and according to our rules, if the biggest power is in the denominator, then I'm going to have a horizontal asymptote at y equals 0, so right on the x-axis. So there's that first part. Now I'm going to factor the top and the bottom. Okay, so the top doesn't factor at all. That's just x plus 4. On the bottom, I'm going to factor what multiplies to negative 20 and adds to negative 1, which is x minus 5 times x plus 4. So here I see that I can go ahead and write my domain, right? That's our third step, is before you start crossing stuff out, make sure you're right about the domain. Here, x can't be 5 or negative 4. Any other number will work, but those two do not. So here I'm going to cross out I'm going to cross out the x plus 4 factor, and that's going to rewrite the equation as just 1 over x minus 5. Again, because I'm taking out the x plus 4 on top and bottom, which means I'm going to have a hole in the graph at negative 4 comma something. If I take negative 4 and plug that in to that x there, I end up with 1 over negative 9. And 1 divided by negative 9 is negative 0.11 repeating. I'm not going to be able to get that exact. Again, this I got from plugging in negative 4. Oh boy, that's a weird 4. Okay, I see I have a vertical asymptote still because that wasn't removed at x equals 5. The x-intercept is what makes the numerator 0, but since the numerator can't equal 0 because it's just the number 1, I know that I have no x-intercepts. And finally, I need to plug in, to find the y-intercept, I'm going to replace x with 0. So if I plug in 0 here for x, I would end up with 1 divided by negative 5. So my y-intercept is going to be 0 comma 1 over negative 5 would be negative 1/5 or negative 0.2. So there's all the information that we have. Now I'm just going to put this on the graph. And again, then we'll use the calculator from there. So I've got a vertical asymptote at 5. Okay, so I'm going to go to 5, 1, 2, 3, 4, 5. Here's my vertical asymptote. We saw earlier that I have a horizontal asymptote at 1. And if you think, this is actually kind of interesting, this goes back to section 8.2. We actually know what that graph's going to look like because that's technically just a reciprocal function, which means it's going to be something like this. If it's simply a number over x. What we do need to include, though, is the fact that there is a hole in the graph at negative 4 comma negative 0.11. So negative 4 comma negative 1, 2, 3, 4, negative 0.11. About right there. I'm going to put an open circle. Again, you can make it kind of obnoxious. And then I'm going to go ahead and just use the calculator to get a picture. I kind of know what it's going to look like, but we can go ahead and just do, again, you can type in either the original or the simplified version after you cancel. That doesn't really matter in the calculator. Either way, we're not going to be able to see the hole in the graph, but x squared minus x minus 20. So I am actually going to type in the original only to confirm what I already know about the graph. So you can see there that we kind of have a vertical asymptote at 4. If I hit the trace button, I can type in 4 for x, and I can see, or sorry, no, the vertical asymptote's at 5, my bad. I can type in 5 and see that I get no y value back. And then I can also type in negative 4 and see that I get no y value back, which is the hole that's happening in the graph right about there. If you want a more complete graph, you can go ahead and go to the table and get some just pick out some actual values. So like 4 comma negative 1 is going to be a nice point to graph 6 comma 1. So 4 negative 1 and 6 comma 1. I'm going to go back here. 4 comma negative 1 and 6 comma positive 1, which makes sense because we know it's going to kind of look like that. That's not very good. It's going to be a little bit more aggressive towards the asymptote. And then on the lower half, I've got a branch that looks like this. Okay. Again, as long as you make it clear that there's a hole in the graph there, that's fine. So there's our sketch of that graph. Okay. XY intercepts, horizontal, vertical asymptote, and then any holes that are in the graph as well. All right, one more real quick. This thing is not factored, but I see that we want to start with the horizontal asymptotes. Those are equal powers. I have x squared on both top and bottom. So if I were to take x squared and divide by x squared, that would simplify to just 1. So that's going to be my horizontal asymptote, is that y equals 1. Okay. If you wanted, you can go ahead and do that right away. So I'm just going to put a dash line, a horizontal asymptote at 1. So I've got that on there. Now I'm going to factor the top and the bottom. The top is going to factor into, what, negative 15, but adds to 2. That's positive 5 and negative 3. And the bottom would factor into, multiplies it to 10, but adds to 7. X plus 5 and x plus 2. So now my domain, don't need to say the whole thing, domain is x can't be negative 5 or negative 2. I see that I can go ahead and cross that out now because I've addressed it. So what happens now? We've got domain's good, factor, horizontal, points of discontinuity. So I know I have a hole in the graph. I'm going to go ahead and write the simplified version actually. So now I have y equals x minus 3 over x plus 2. And this is going to be what I use for the rest of the calculations. So I've got a hole in the graph at, I know the x coordinate is negative 5 because that's the factor that we canceled out. I'm going to plug in negative 5 for both x's, negative 5 minus 3 over negative 5 plus 2. That ends up being negative 8 over 3. Negative 8 divided by negative 3, which is about 2.6 repeating. Okay, so I'm going to say about 2.6 repeating is my hole in the graph. I know I have a vertical asymptote at negative 2. I've got a vertical asymptote at x equals negative 2 because that one was not removable. I couldn't cancel it out. I see up top here I do have a factor left, which is x minus 3. Again, I could just look right here as well, which means the x-intercept is going to be at 3 comma 0 because the x value of 3 is what would make the numerator equal 0. And then finally I have the y-intercept, which is what happens when I plug in 0 for x. And if I were to do that, if I were to make both of these x's zeros, I would have negative 3 over positive 2, which is negative 1.5. So all that said, I'm going to go ahead and put this on there. I already have my horizontal asymptote. I'm going to go ahead and put on the vertical asymptote at negative 2. The hole in the graph is, nope, well, I could do that as well. The hole is at negative 5 comma 2.6 repeating. So 1, 2, 3, 4, 5, 1, 2.6 repeating. So about right there. But again, this is a hole in the graph. I have an x-intercept of 3 comma 0, 1, 2, 3. I have a y-intercept of 0 comma negative 1.5. Okay. So those are the 3 points that I have right now. I'm going to guess this is something that looks like this. And I don't know what happens here, but I'm guessing probably something like that. Let's take a look, though, at the calculator. Whoops. Let's take a look at the calculator and see what there is to see. What was our original? X squared plus 2x. Again, you could just type in the simplified version. I'm going to go ahead and type in the original just to confirm that the hole in the graph is where I think it is. X squared plus 2x minus 15. This is a nice way to kind of check your factoring too, to make sure you factored it right. X squared plus 7x plus 10. Okay. So I'm going to go ahead and hit graph. Ooh, that's fun. You can actually visibly see the hole in the graph. That's the first time I've ever seen a TI piece of equipment able to do it, so that's kind of cool. You probably don't think it's cool, but it's kind of sweet to actually see the break in the graph there. We can see the vertical asymptote. We can see the horizontal asymptote. This is creeping up towards 1. This is going down towards 1. And then we've got that hole in the graph. So it is basically what we thought it would look like. So I'm going to go ahead and just like that, something like that, and something like that. Again, if you wanted to have actual coordinates, I'm sure if we go to the table real quick, then we'll wrap this up. I'm sure if we go to the table, we could see, you've got some coordinates here, -3, 6, and -1, 4. So if you're looking 1, 2, 3, 4, 5, 6. So if you're looking for actual like coordinates to kind of bolster your graph a little bit, you could do that. I was actually off a little bit on this one, but yeah, that about does it. Again, we're doing a lot of information for one graph, but we are using technology to help us after that. We're going to do a little activity in class to talk through this stuff. And again, no additional homework for 8.3.3 because I've done enough. So there you go.